Hello, and thank you for watching this video about center of mass and how it relates to the stability of systems. First of all, let's review what mass is. Mass is a measure of how much matter, or stuff, is in an object. It is similar to weight. If something weighs a lot, that means its mass is high. To measure mass, we might use a triple B balance or an electric scale. In science, when we measure mass, we most often use the units of grams and kilograms. The center of mass of an object is the average location of all of the mass in that object. In other words, it is the point in an object at which the whole mass is concentrated. That may be difficult to understand, so I'll just show you. For this sphere, as long as all of its matter is evenly distributed throughout it and it isn't more heavy in one spot, the center of mass would be smack dab in the very center. If I had a cube and all of the matter was spread evenly throughout it, its center of mass would be smack dab in the center. And with this triangle, if its matter is also spread evenly throughout it and not more heavy in a specific spot, its center of mass would also be right in the center. I imagine you get the picture. If it is a regular shape with uniform mass all throughout, its center of mass will be right in the center of the shape. Center of mass is a little more tricky for objects that are not regular shapes, like this wrench. This blue line shows the center of the wrench, but the center of mass is going to be closer to the left end of the wrench because there's more mass on that end. If you were going to try to balance the wrench on your finger would need to be closer to the heavier end in order to get it to balance. Have you ever tried to balance something long on your finger, like a ruler or a pencil? When you do that, you're trying to find the center of mass of the object so you can get it to balance. With an object like a ruler that is pretty uniform throughout, you'll find the center of mass is in the center of the object. As long as your finger matches up with the center of mass, you will be able to balance the ruler. Why? Because of gravity. Gravity is constantly pulling down on that ruler, and your finger is the only thing stopping it. If your finger is not supporting the ruler at its center of mass, the ruler will fall. So in order for any object to be stable and supported, it must be supported where the gravity is pulling it downward, which is at its center of mass. Here are two different systems. The triangle on the left is a system, and the triangle on the right is another system. Can you tell which one is stable and which one is unstable? I bet you are able to figure it out. The one on the left is unstable, and the one on the right is stable. But why? How can we explain that? We have learned that a stable system will return to its original state of equilibrium after a disturbance. We can look at this triangle sitting on one of its sides and know that if we push it or tip it just a little bit, it will fall right back down in this position, right back into equilibrium. Why? Because gravity is pulling down on that triangle's center of mass. Gravity will be pulling down on that triangle to bring it down to its original position. This is why the triangle is stable, because one of its large sides is in contact with the table and it is being supported at its center of mass. It is a different story for the unstable system on the left. We have learned that an unstable system will not return to its original state of equilibrium after a disturbance. We can look at that triangle and immediately know that with it being tilted in that way and just standing on a corner, it's not going to stay that way. Why? Because again, gravity is pulling down on its center of mass. Its center of mass is not currently being supported by the table. As you can see, the bright blue arrow is coming directly downward from the center, but that area of the triangle is not touching the table, so it's not being supported. The triangle is unstable and cannot balance like that on its own. When disturbed, the triangle will fall down onto its bottom side, just like the stable system on the right. but it will not be able to return to standing up on the corner like that, which means it is an unstable system. Unstable systems cannot return to their original state of equilibrium after being disturbed.